Yo, hello guys, welcome to my video. This is my first video and my first live stream. I don't know how it's gonna go, but I'll try my best. So I'm doing this stream in which I will be showing my game engine. I will be working on my game engine from scratch. And the thing is, I want to document my engine from the beginning. That's why I'm doing it. So I have already created a directory on GitHub for that, so I can just clone it, you know, here. Uh, so I named it Eclipse Engine, and it's pretty straightforward, just license and readme. So now we will be adding the features that you want to add. Oh shit, bro, I just added in the main directory. I don't want to add in the main directory, bro. We have to add in the desktop. Okay, so I'm gonna move it to desktop. That's why I was wondering, man, where's gone. You know, we have only two files here. Let's start. So I'm gonna be using CLion. I am not uh I am not actually in line with CLion. I never used it. I'm just using like a new user. Even my engine that I'm building is gonna be new, and everything that I'm gonna do it like a new person, like a person who has never done it before. I will be researching on it and I will be doing it like that way, so that other person and other people can learn from me, like how I'm doing, and take inspiration or can actually just build their own. And when they have any problem, just take help from my engineer. Okay, that's so easy. So let's begin with that, and here we have readme and license. So let's start with CLion. I will build a cmake list.txt file first because we'll be using cmake for that. C++ and Vulkan. See, I tried Vulkan like a lot of times, but to be honest, it's pretty hard. So I have completed the tutorial for Vulkan, but the thing is, it's very hard, man. Like literally very hard. It's hard to understand how it's working. I tried to implement some of the principles for my engine, like using structs. So I will be using like the struct initialization. My engine won't be using like any object-oriented programming. Very little, like only where it's required. Else, we will be following the namespace, and everywhere will be namespaces and not a class. That's just how it's gonna be. So let's start with cmake minimum required and version 3.10. That's pretty good, yeah. And yeah, we are also gonna be we'll be using C++23 because the version is it's great actually. The standard of C++ is actually great. Like it has print. I just saw Journal's video. He was telling about like expected. That expected thing is also very cool, you know. Just use that expected and it's gonna be nice. Like the error handling is so good. Not good for the old engines. Like the old CMake, I will not be using any old CMake. I'm using 3.10. In C++, like I will be using 23 standard and no shared libraries for now, because I'm not gonna take on the hassle of like dead DLLs and all that stuff. Anyways, we are on Linux, so I don't have Windows installation right now, so I'll be using SDL because I don't want to be like building for Windows and building for Linux and building for Windows. Like I put something here and it breaks on Linux like that shit. I don't want to do that. So I'll be using SDL for that. It's gonna be good like that way. We'll also get sound and timer and all that things. We don't need to rely on Chrono for that. Then that's gonna be better. So let's give the project Eclipse Engine. That's the name of the project, and the SLN file on Windows, and like the project name on Linux, that will be kept. Now let's set some standards. CMake CXX, that's a C++ compiler. Standard, I guess that's how you write it. Yeah, 23. Set CMake CXX standard required on, set, build, shared, libs, and off. Okay, so we're gonna be not focusing on Vulkan all that things right now. Let's build a basic ecosystem for our working place, like for our engine. So how are we gonna structure our engine first? I guess let's use something like an engine folder that includes all the files. It's gonna be good that way. So let's start with file. No, we don't need that. We can just directly create a add executable, and let's name it engine, and main in engine slash engine.cpp. That's pretty fair enough, I guess. Uh, mm, oh, well, that's all right now. So we got an executable, add executable. Mm, I guess we are missing something. Yeah, we are missing add or add include directories. Let's keep it cmake source there. That's good. I like to keep it like that so I can just include stuff from the main engine itself. Yeah. So it's made here. Whew. Wow, it shows 11 lines and there is 12. That's great. Okay, so let's build it now. First we will be using C-line. I just found like this IDE became free for like non-commercial use, and that's actually great. Don't pass any generator explicitly. I don't know what to do. Uh, let's use Ninja. We won't get any color output. We get color output with CMake and make files. That's the best actually. I just spit out some stuff that is not even relevant to the information that I'm speaking. That's a problem with me. Hope it gets fixed later. Right now, that's how it is. Now, what is an unshallow repository? What does that even mean? Oh, wait, it does not even mean. Okay, wait a minute. First, let me get the engine to compile. Okay, the engine. Whole source file, not engine. And see, that's automatically. And it's already there. Okay, don't ask. Add. Okay. Settings can be added to create. Okay, always add. What is this? Okay. What is a unshallow repository? What is shallow? I can write. Okay, so like shallow file. Let's see what does it say. Oh, understood. So I did that depth thing. I don't want to unshallow it. That's good. So let's start with basic stuff. Let's see if C++23 works. I guess it will work, but let's just check. Damn, it works, man. Okay, so we got a print working because now that shit works. Now we got engine.cpp working. Now let's build like a folder. Let's call it mm, something, like common. Yeah, it's gonna be common stuff like memory management. That's important. But first, we're gonna start with error handling, like the errors that are gonna be handled. So, header file. I prefer HPP. Why the hell is there no HPP here, bro? What the hell? Yeah, that's what I want, man. Yep. And let's keep it logger. Uh, I don't think we need that because we'll be using like something. What do we call it, man? Like I don't even remember the name. Okay, so there was something in common. Yeah, templates. Like the templates we're gonna use come in only HPP file. That's a problem, but that's okay. They have to do it. They have to be like that way. So we're gonna be including a print function. Does print have like something like log? No. So first of all, let's move this from here. Oh hell no, bro. Wait a minute. Okay, and we should include engine common log.hpp. That's great. And here we can start with namespace called engine. Actually, engine is a common word. Let's do Eclipse, like that's better. Eclipse and then a logger and then display log. Logger logs, yeah, that's what it does. Okay, we need to get some levels. Again, look like something class enum. Okay, logger log level. That's a nice name. Man, what the hell do you call it, man? I don't even know, man. How do we do it? I just forgot the things. I don't write so much C++. So I had my old engines. This is my friend's engine. Basically, it's mine. So, okay. It's not third party. What the hell am I doing, man? It's like somewhere in. Oh, this also is not that. This is not that. Okay, so we got like an engine. Okay, here we got it. So what we were doing? We were doing like HPP enum class log level. Man, that's what I did, man. To do something else. Oh, enum class. Damn, bro. C++ is different. That's okay. We can start with like one is info. Let's start with the lowest level, info. Then go to warning. Yeah, that's all right. Uh, warning. We got an error. And does it have something else? Fatal. Yeah, that's what I was thinking. But I don't think we need fatal. Info warning error. That's it. Okay, so we got that much working. Let's create a log level. And now avoid logger. Uh, log info, no, just like log. Okay, so we can start with log level. What's the log level? It's here. Log level, and we call it level. Okay, why not just pass a string, a const std string ampersand, and this is the error. You can call it error. No, let's call it just input like this. Okay, nope, that's not good. Let's call it data. Oh, and then here we start, and then we print ln. We print it based on like what's the thing. So we can do log level, like a switch for log level, a level log here switch. Okay, if we do a case log level info, then we should do like a std print info, and it should contain data, but like that data is not gonna be working without the arguments, so we can do like an std format, std string out is equal to std format. I don't know, we're gonna forward them like that. Yeah, it's getting pretty good, but not there at that level. Like it's annoying still coming in between my work, but that's okay. And then we put the out here. That's what we do. Let's just check if this thing works. I don't even have any clue it's gonna work. Do like an eclipse logger log, and a log like eclipse logger log level info hello world. This is 80 91. Okay, whatever. Okay, so that's a problem. So we say that it's a and a const string and, so we're taking a constant. So we can instant do string ampersand data arguments, and then we do a level switch. Oh wow. Okay. Okay. Default case not handled. Okay. Info and out. That can be called std format. And what does it return? We don't even have a string, but that print will handle that. Okay, so what's this? So this is like v format, get, should we make format arguments? Yo, I just think I need to study about this shit, man. I just even don't know what to do, man. It's like, it's hard to do, like templates. I never did them before. This passing around and formats thing. I don't use C++ much. Like I do, but I don't. I don't use the advanced features. So let's just create a simple version of it for now. For now, man. What's the problem, man? Nested namespace can be concatenated. Okay, what is that? Oh, damn. Okay, so we can start with a logger that logs something pretty fast. Like we need a const function to like const expr like function. Can like have a const expr function? I hope we can. Let's try. If we just pass out the arguments, like return it to log itself, like steady print message, we will go simple easy steps and then we will go to the difficult one. Okay, this should, see, this is doesn't work because call to const eval function, not a constant expression. This says it's not a constant expression, while it is, but not this. That only works for classes, yeah. Inline. Inline can actually improve performance. So we got std print here, a message, and that's the message. Okay, so what's the issue? This is not a const eval, man. I just hope that recompiling it fixes it, but it doesn't. What does that do? That works? Nope. Okay, let me just read the message. That's better. Okay, the call to const eval function, std basic format string char message std clx11 basic string c star is not a, what is it not? What is it not? It's not a constant expression. Do we want it to be constant expression? If I just remove this, oh, so okay, understood what I want to do. So the thing is, this is what it wants to do. So it wants this. Yep, it wants this. So we can do like info hello world. This is something. This is parentheses, but we can make it actually work. Now, if you get multiple of them using template and a type name arguments, and we do an arguments like that, something changes? No, it just works because it's a create function. Like if you just do this is somebody, that's good. Nothing should happen actually. Okay, but we can actually fix that by just doing an info and this, and then inside of the message, oh, what the hell do I do? Okay, inside of the message we gonna create here a std string called out and make it an std format. It takes a message and then takes an argument, and then we do the out, and that should work. I don't know. So what was that, like v format? No matching function for call v format. Okay. Oh, so what does the format do? Std format takes in the arguments. It takes the arguments and takes a message and then just converts it into the output. You know. So what's the problem? Let's see. If you compile this, we get an error is in instantation of void eclipse log with argument this. Okay, call to const eval function std basic format string char const char pointer and message is not a constant expression. So it's not a constant expression. That's the thing, that this message is not a constant expression, but here we see it's a constant, but we are just making the pointer constant, this constructor, not the data itself. So what if we take const char pointer? Oh, so now it's another problem. Call to const eval function. What's this? Wait a minute. Let me check something out. Let's just check Google, like how to use std format. Okay, so let's see this. Oh hell no, bro, it just takes a std string view. That's the problem. Okay, let's see next. I guess the print should include the format, yeah. Yeah, see, it includes the format. We don't need that format. Explicitly, we don't need that, but we can add if you want to. See, it's using a constant expression here. A R value. This is an R value, but we want to use a non-R value here. Okay. What's this? Let's see. Okay, so sprintf std format and hello world. Can we create like a const string here and out and make this like that? It won't work. Let's just run it. So is there a format string? Wait a minute, what does format take? Okay, std format arguments. Std format string arguments. It takes a format string. Oh, what's that? I never saw that, to be honest. What's this? It works. And it just works. So what's this for then? This should do something? Not just doing it for fun. Huh. I guess this has to do something with that. So we got this working. Info hello world, this is somebody. Okay, let's try to do something here. And we got this is somebody else, and that's great. But the thing is that once we got this working, we gotta get some more stuff of that working, and that is the log type. Okay, so what log it's gonna take? That's the thing now. So now, right now it's just taking arguments, multiple arguments. Now I want to take what type of log we want to do. Info log, a warning log, or a error log. Like we want it to be done dynamically, we can do that. Yeah, a log is log. This is gonna be default. You're gonna just paste that thing, paste that thing. No, only one time, I guess. Okay, and this time we create something uh, called a enum class called logger level. That is a info, that is warning, that is error, and that's it. Like, that's it, nothing else in it. Like a level, uh, a level like that, and then we can create a switch case for the level. Ooh. For info, and when we break, and just copy that because I'm lazy, as you can see that. Let's go step by step. Okay, so we got it that way. And then there's a case default, and that is like info, a warning, error, and a none. No level. Like if there's a no level, we don't print it. So what's that, man? Let's make it like default and do nothing. We just break. Okay, so the curly brackets are making me rip off, like yeah, that's better. So close the switch case. Damn, let me just write switch. It's gonna be easy to read. So that's a switch, and there we go. But now after doing that, we can just do a eclipse, a logger, and then a log by doing a log, and we can log hello world just came here to say hi, and that should work. And now if I don't want that, just write a eclipse, just write a logger, just like a level and error. Man, that's serious. Oh shit, I just pressed the debug button. Anyways, it works. Just came here to say hi, but there's an error this time. Okay, that's done. Now we need a bold thing here. This thing should be bold. Okay, bold and colorful. So, how to make it bold and colorful? Bold and colorful. I don't know what I'm writing, bro. Like, I'm mad. See, let's just get that off my brain, okay? We need to be colorful stuff. That's bold. So, styling text in format std, like in std print. Let's see if there's something. Okay, we got the reference of cpp reference. Oh hell no, that it hurts, man. Very bright. Can we print colorful stuff? Oh, it says use escape sequences control color within the terminal. Okay, so it doesn't have because, but it's made with FMT, bro. It should have, man. Why? Okay. What the hell, man? What's this? But isn't that different for every of them? Like 31 is red codex color. This is green background. 1 is for bold and 0 for to reset all attributes. Okay. Let's see this one works. So it says for me to use like a blue color. Okay, I will use a blue color. Let's use a green first because that's what it says. How do I keep it on top, man? I can't keep it on top. Damn, bro. Just let's make it like that. Okay, let's just be full screen. Let's just see. So, X. So I forgot. X1B. Then a bracket open. Then what we do? 1M, 31M for red color. 31. And then what's the M? 1 for M. Be 31M. Okay. And 0M. It says for reset. Oh, it's an error. Okay, that works. But the thing is, we need the bold stuff too. Gonna paste it again and make it 1. Gotta help. Yep, that works. So we can create some const expers like that. Like a const expert, and we can call it level color format. It's a struct actually. Can we use a struct for that? I guess we can, but we need to be just able to access, you know. I'm a C type guy. I like C better, so why not just use a define here? We define a red, a B red. Okay, we define a B red bread. What the hell, man? B for bold, a red bold color, and X1B 31M, and again X1B 0M. That's it. And we can have hashtag define. It is set. We need to be for that only, so we can just call it to be format red B, red bold, format reset slash xp1 0m. And paste it red. We need a blue. We need a orange. Okay, red and orange. Cyan. Okay, so let's do like and see color codes. Okay, regular color, bold color. Oh wait, we have like that bold stuff too. Let's see that. X1 31M. That's cool. Let's try with red. Oh, it just gives an error straight away. Let's stay with that. So 31M for red. For yellow, we can make it yellow. Yeah, yellow is better. Yellow. Okay, yellow is 33. And cyan is 36. Okay. And then we should do is not make that stuff complicated, but instead do this. And then do a format. For info, it should be cyan, bold, and format reset. Copy that. Let's check that. Okay, we don't get anything. Now what's the reason? Okay, that should work, but it doesn't work. I don't know what the hell is the reason for that. That should work. Does that work? Let's see. Oh, that works, man. What's that? Oh, it works. So what's that? It's a slash E1M slash E0M. Bold. Regular color. 1 for underline. Okay, 4 for underline. What if you try that? Let's copy that. And in cyan. Let's just do that. But we got an error here. What's the error? Is that the error? Oh, damn. Let's see what's the error. It works. I don't know what's the error, man. C-Line is making fun of me, man, I guess. It's just fooling me around. I can't even see the error snippet, bro. What the hell? What's that? Let's just leave it like that. For yellow. For red. Oh, for reset. That works. Warning can be done using format C. Okay, format yellow. B. Format reset. And for error, format yellow B. No, it's a red, man. It's a red. Format reset. That's it. It should work. Okay, let's try making it an warning. Should get a pretty yellow color. Yep. It's not pretty, but it's okay. Or red. Oh man, not red, man. Error. And now none. We don't want the output. That. That's good. And we forgot to update for that. Actually, we don't need to have two different. Oh hell, nah, bro. No two different definitions. Let's just utilize the old definition of that. What was that, by the way? Oh, put it here and just call the log again. This time, take the format string message and arguments. But here, Let's make it a level info. We got no error. That means it should work. If I remove that, it should just work. And yep, it works. That's great, but can it handle any struct? Let's see. A struct x can be given a std string n and then a x. We can create a x a and a dot n is equal to hello world. Int x a dot x is equal to 99. Okay, let's just say I want to print that. I do that, and then I put an x here. Actually, it's not an x, it's a, and that should not work, I guess. Yeah, so we don't have a constructor for that, I guess. That's what you call it. We got a log. It says we need a constant expression, but if we try to do like a dot n, that should work. If we can do a dot x, that should also work. Yeah, but it doesn't work if you just give the whole struct. Yeah, but what can we do is we can, whenever we are using this struct, we can just respond to this message, like whenever the log requires a struct. We saw it in a journal video, you can check it out in journal. Right now I'm not doing that. So here we are. I wrote a basic system right now. Next thing that I have to do, what to do next? Got a log level working with this error squiggles. We can actually just not make it define. Let's just do const expr std string view and format. And here we do an equal to. Huh. Expected a semicolon. Semicolon. That should not work. String view namespace does not have a name type. Okay, so I can just include this stuff above. And I really don't know how to use const expr, but I will try my best. Let's try a string. Don't we use an equal to? I don't think so. Let's just make it define. That's better. Oh wow. Did I mess something up? Oh, so that was the error. Wait. So just fix that like with an dot x. Let's just check out how to use Enconst Expert, It's just like a normal data type. I'm getting an error. Oh man, like how much dumb can I be? Not put a semicolon. Because otherwise you could define I didn't have to use the semicolon. But now I have to. So that's a 99. And if we just utilize like a string view, it's gonna be better. Yep, it just works. So I guess that's it for my logger. Got a level here. We got no level here. That's it for now. We will be actually adding this constructor thing. Next, we should go towards memory alignment, I guess. Memory alignment and memory allocation. We need a memory allocation system. So we can create like a memory pool. Yeah. And this thing is very annoying. Damn man, it's so annoying. Let's just remove this. Yep. So we can create a memory allocator. Whoa, it's great. We got our stuff working here. Nothing else. Let's restart. Whoa. So now we're gonna be doing some hard stuff. Okay. Okay, so what does hard stuff mean? It's not really hard, but let's start with like a memory Like we have a memory here, we have two types of memory. We have a stack memory that's aligned straight like a stack. You can see, yeah, like if you rotate it 90-degree, you're gonna see like a stack of books, you can say, whatever. And what we do in this is we put in the memory whatever data we want to put in the memory, we just put it in and we push it. That's basically push. That's a stack memory. That is used by our compilers, like whenever we do like an int, whenever we create an int or we create like a char. But when we create something using malloc, that is memory allocation, we do not allocate from the stack because stack is managed by our operating system. So what happens is, like, if we create something, a memory in a stack, it's created by a compiler, and on exit, the compiler or the operating system, you can say, automatically deletes away all that memory that you had allocated, thus freeing up system resources for another applications. But now here we have malloc. Here you are responsible for everything, and it's stored in something called a heap memory. It's useful for large storage, like some large things, like I want to store a file, 3D model file. So in a 3D model, like in .obj, we have something like a v, then x, y, z position, another v, x, y, z. This is the vertex. We have like a vn for the normals. So what we do here is we take this stuff, we put that into our memory. But how do we put that into a memory? We cannot be just like, yo, stack, allocate that much memory for me. Because in stack is limited space. And every application gets a limited stack space. And the thing with stack is it can be used for small things that need to be allocated. But things that are large enough, we need to use the heap memory. Heap is like whatever you call like a pile of things kept on each other like that. We don't care how it's kept, it's just thrown away inside the heap. Every application manages heap on its own. Like now we are having languages which have their own memory management systems like Java and all that, but still the JVM below it manages it by itself, while not actually being managed by the person who's writing the code for JVM, but the JVM is managing it. So basically it's being managed by the application. So operating system does not interfere much. It does, but not much. Like there's a lot of things to take in point for that, which I won't be telling, you know, it's complicated. So here we go. It's even irrelevant for this topic right now. So what I'm gonna do is take a block size, allocate that block size of memory, and after that block size memory is allocated, what happens is if I want to allocate more memory, like this is the memory I allocate like a 2046 of bytes. Now I require more memory, my application requires more memory. So what will it do? It will create a new block and link it to the old block like a linked list, and new one linked it to the old one. So every time we, and yeah, and if we have some data that is even larger than the block size, we increase the block size. Then we create a block size, and that's it. Like a larger block for that size, like a, let's call it large block. Huh, don't mind my handwriting, but like it's large block of memory that we allocate, and this is the small block, and then just tie it to another one, and like these are getting filled less and less like that, filled less and less like that, and it's being filled like that. Whenever we need to allocate something small, it checks memory here, not there, goes to next, memory here, not there. Next, oh, I have much memory here, so I'll just allocate this stuff. And here it's get allocated. Or it keeps going in. It goes, and does not find anything. And then we create a new block for that if it's small enough. But if it's not small enough, we create a larger block for that. But now the thing is, this I feel is slower, but this is the model that we're going to use for simplicity right now. Afterwards, we're going to expand. We need to control our memory ourselves. That's the thing. In the future, I'm going to add a deletion system because see, think of it like I take shaders, then I compile the shaders, then I output them into like an .spv file. After compiling them, I need to clear up the memory that is used. Yeah, this is the memory I use. I need to clear it up. But if I'm using this technique, I cannot just clear it up and it will be waste of memory. Actual waste of memory. I don't want that. But I don't even want to use malloc, which allows me to do that because it's slow. It asks for operating system to get memory and checks along all the way to find some memory and then hands it to our application, but it's slow because it needs to check a lot of memory while we need to check only a small sum of memory, like a small amount. So what can we do about that is if we can have like a vector, but see if we have a vector that stores all the memory allocations happened here, it's anyways resizing itself. So resizing means it's using its own other memory, which we don't want it to use. We want to use only our memory systems, not using normal C++ stuff. Yeah, but then it comes that std string, what we call it, that also allocates memory, and I use that here to allocate some memory stuff where it's gone in the logger.hpp. And I can't do anything about that right now. Right now, it's gonna be like this, but I'm gonna change it afterwards. I guess let's create first memory, then let's create a string system. Yeah, we don't want to use systems here. We can just use like a string system. That string system is gonna be like using our memory allocator, like what we are using right now, and it's gonna keep in mind that we are using that and optimize for only that thing. And that's gonna make it like a fast version of string and more optimized version of string. That's not like a normal version, it's optimized version of string that is gonna be just using the memory it requires and not like allocating stuff all over the memory and just polluting the stuff. That's the thing. We don't want to pollute the stuff. We don't want to pollute the memory. We want it to be controlled because it's a game engine, and a game engine the stuff should be controlled, because if it's not controlled, that means we are wasting stuff. We are wasting performance, we are wasting system resources, and a lot of stuff. Like I will show you an example. Like there is the Valve Source 2 engine and the CS2 that runs on Linux on the Intel integrated GPUs which has shared VRAM. So there is a problem for that in Vulkan. That Vulkan, whenever you share memory from like the system RAM to VRAM, like it's just in the same place, so it just copies itself and duplicates itself and just creates like double memory, does not delete it from the RAM. That's the problem. It's not able to do that. That's that's bad code right there. That's bad code. And that's what CS2 does, and that's why I have to use like uh I have 16 GB RAM and still I have to use like a ZRAM or a swap memory to circumvent with this stuff, else it's not gonna be usable. It just crashes at compiling shaders. Same thing's gonna happen then with us. We don't want that to happen. We want that whatever we code, whatever we write should be optimized enough so our so our engine can not waste resources. So what we're gonna do with that, we're gonna create something better, a plan for our memory. We should have a more better way to represent memory. We have another part like a contagious memory, which is continuous, and like if you want to increase it, allocate new memory here that is larger, then delete this memory by first copying it here. But the thing is copy. Whenever we are running out of space, we just delete, we copy, and that causes a hiccup, means a frame drop. We get a frame drop. That's not what we want. We don't want a frame drop. We want it to be smooth. So that's the thing. We need to keep in track all the pointers that are pointed to that memory position, so we can actually do something like that, like create a pointer 1 which contains a pointer value for the real stuff, it points here, and another pointer that we give to the other components of engine, and that points to this pointer. So we can just change this pointer anywhere by allocating memory somewhere else quickly and change that stuff and delete and disconnect that stuff and then just free it up. That's gonna be that's gonna keep this relevant, like this is just pointing here, but this points here. This is one theory that we can do. We have another theory. That theory can be like a pointer that is keeping in mind like a pointer array contains all the other pointers, and we have like a index system to access them like 0 1 2, or like a list system to access them like a string. I want this pointer, I want to access this pointer, and it just points to that pointer there. Yeah, it's kept there, take it. But I guess this is a better one. But still, if I don't want to copy the memory around, we need to do that for vector, because like a vector is gonna be contagious. So we can have like a vector here. It's gonna be taking memory. So a vector will work normally like this is a memory block, and this is the capacity of the vector right now. So what happens is, like, if I want to increase its size because it's getting insufficient space, so what I do is I double the capacity. For MSVC it's a little different. For GCC we double the capacity. For MSVC it's like 1.5, I guess, into 1.5. And then what we do is we copy the memory to here, and after copying the memory we delete the stuff. That's a new vector. We just point here now. This vector points here, and that's how it should work, like that. But if you're going to use the linked list system, we are wasting memory. Or we can just keep every memory block as a linked list and just disconnect from linked list when we don't need that. But it's gonna be slow because we need to run a loop for search. So we need a different technique to do that. We're gonna use something faster and more efficient for now. For now, let's implement a simple memory system. It's gonna be a memory pool. Okay, it's gonna be in the HTTP file. A namespace, Eclipse, memory, and here in memory we got a pool. Let's have like a memory, a struct memory. It should contain the beginning, the end, and current. And we have a struct create info. This should contain a size. So first we need to get another CPP file, a header file called types.hpp. Let's make it a pragma. That's a new technique for do that. Old stuff. So let's not knock it into namespaces. Let it be normal. First thing to do is include an std int. What's this GCC? Let's check it out. Okay, so int 8. So we get this all. That's great. Let's get int. We have an int like event header underscore t. We should check it out here. Okay, here we have all of them. It is an scstd int. Okay, here where it's defined. Cstd int. Okay, and here we should have it. Okay, here we got it. Let's go put this left and type here. Let's go for like a uint. Uint header underscore t. We gotta get that. Fast types. We got unsigned uint fast 8. If you don't want a fast type, what do we do? Word size long unsigned long int. A long int. And we can do using u64 is equal to unsigned long. Why it is like that? Like a long is a 64. So what is a long? Oh, I write C++. Let's go to engine.cpp and here engine common types.spp and u64 uint 64 max. Let's see if it works. So it's correct, but what if I increase one? It works. Whoa, into 10. Damn, it works, man. That shouldn't work. But that also works, man. Like, how the hell is that possible? Right, let's do a eclipse logger log. Okay, we get that. If I don't define it, we get a garbage value, which we shouldn't, because we should use this. Yep, we should use that. That's our default initializer. But we can do a uint64 max. That's what we get. But that's what we shouldn't get. Like, how can... Wait, if I just... It's 1, 5. If I increase 1, it should get to 0. Okay. So that's the thing. It becomes 0. If I do another plus, it should become 1. Yeah, it becomes 1. So it's a 64-bit only, yeah. So I don't know why didn't they use like a long int? What's the meaning for that? I guess the fast means like it's trying to allocate a large size for the smaller one also to actually align things. So we are aligning here. Let's just do like a u int. Oh, using u16, using short, and using u32 is 8 is byte unsigned char, but a char is 8 bytes, but bits 8 bits, yeah, it's 8 bit, it's 8 bit thing, yeah. That's how we do it. But what about an I? So just do that and make it an I. Just do that, make it an long int short char. That's more explicit, you know, more explicit than long int short char. Let's create a I632 x, that's 0. This stuff works and this does good. Okay, so we got types working. So the whole thing about fast types is that it allocates like 64-bit, like it checks the word size. What's a word size? If defined x86 64 and defined ILB 32, so it's checking which 64-bit processor. And if it's a 64-bit processor, we are just trying to allocate everything as 64 bits, so we are not misaligning. So the thing is, like, we don't misalign stuff. How don't we misalign stuff? Let me tell. Like this is a memory block, and for a 64-bit system, let's think it's a 64-bit. This is 64 block. 64. So what happens is like if we allocate like something, we allocate like a 32-bit, and then we allocate a 64-bit. So we are allocating basically a 32-bit, and then we are allocating a 64-bit block. So what happens is that whenever 30-bit and a 64-bit block is integrated together, here is the problem. This is misaligned. This is misaligned. So what happens is after misalignment, the CPU has to do double fetches. I'll show you how. Imagine this is like a memory block in your stack memory, and we got 64 bits, 64 bit, 64 bit, 64 bit, like that. This each of them is 64 bit, but now what we do is we allocate like a 16-bit block, a 32-bit block, another 32-bit block. So now the data is misaligned. Now if I want to integrate a 64-bit block now, so we have to do 64-bit like that. Now this is a 64-bit block. So what happens is this comes between these two blocks. So to pass it to a CPU, we have to give away this block by trimming this away, and then this block. So it takes two CPU fetches to do that. But now if we throw our memory into dump and we just allocate for a 16-bit, we allocate 64-bit, for another 16-bit we allocate 64-bit, for a 32-bit we allocate 64-bit, and then another 64-bit we allocate, oh hell no bro, another 64-bit we allocate a 64-bit. And now what happens is if we want to pass it to the CPU, it's gonna go in one fetch because it's inside a single block aligned. We are aligned in memory, we are not misaligned like this. So that's why it's a fast. Now fast has perks, but I don't think so we should use it. But for performance reasons we should use it. That's the thing. Why not just make everything as a fast? So how do they implement fast? They do it like a word size check. See, we're gonna be just making it for 64-bit systems. We're not gonna be checking 32-bit. Here, this is like a fast 8, a fast 16, fast 32, fast 64. So what we're gonna do is we're gonna do a long int, a long int, a long int, signed char. So let's try to do something. So go to engine, we do a long int x is equal to 0, u64, I64 actually, y is equal to 0. Then what we do is eclipse logger log x is equal to this, y is equal to this, x comma y. This should print 0 comma 0. Okay, now if you do is instead of this x size of x and size of y, what should we get? We get an error. What's the problem with that? Cannot find declaration to go to. Okay, cs cstd int. No, it's not a cs, it is cstd lib. Yep, that. Yo, let's just use like a let's use a printf for now. X is equal to %d, y is equal to %d, size of x, size of y, and it prints 8 comma 8. So both are same, not difference. But like the thing is that in I64 and long int, and here what we are implementing. Let's see what we implemented in this. We implemented a long. But now for a uint, we do an unsigned char, unsigned long int. Now let's see what is this. Unsigned long and unsigned long int. Let's see what's the difference. Unsigned long int. Let's make it u64. Now let's print it. Same thing. See, that's the thing. So I can just name it like anything I want. Doesn't matter. So in a create info, okay. We were doing that. I just forgot that, man. We should have like an alignment system. Hashtag ifdef align all ECL align all and if else. So what they're doing is, except for like the int 8, that is a char, here we're gonna just make it like a char. assigned char, we can just say, but I'm just saying I'm gonna say it's char. And for this, let's make it a for 8 here. Let's make it a char, an unsigned char, and that's all. Now we can just define ECL align all, like ECL align all. We can do that. Enable for alignment. Okay. Create info into cat is U64 block size. Okay, that's the block size. Now we got a block size. I don't think so we need a block size for that, but let's just have it because we're gonna being having a static memory system right now. We are not creating a dynamic one. I did it before, but that was like slow as hell, so I'm not gonna do that. So yeah, we should just have it like a size, and then everyone will have a void memory, a memory and a pointer that does a create, and a memory that does a create info that takes like a reference, and then a void that destroys it. So a create and a destroy, just like it's old times. So we create and then we destroy the memory from here. So we just create the memory. It's done. That's how we create it. And for destroying, we do a free from memory begin. We do a free from memory. That's how we get a memory pool. Now let's see what is it saying. Like your initializing cost over duplicate the time name. Oh, it says use auto. And why the hell do you use a pointer if you can just use an auto like that? Oh, we can use static cast. Static cast is also good. And what does it say? I don't want to make it a const. Oh, static cast, I guess, yeah. See, the ID is pretty good. We got a memory CPP stuff done. Let's go to engine. Let's do a memory pointer. Let's call it a memory. Let's call it engine memory, or let's call it main memory pool is equal to eclipse memory create, and every of our namespace will follow the same thing, the same style like this one until it's absolutely not required. What I recommend, like, we should have option to put it like that, 102096 like that. Yeah. So what I'm gonna do is in memory HPP here in CPP I'm gonna have another function. Basically, yeah, first it told me to increase the sound, like, yeah, I need to increase my microphone volume. Let me check that out. Wait, this is like sync offset and volume. Let's make it like 10 decibels. How's that now? It's like better. Is my volume better? Hello, hello, hello. Is my volume better now? Okay, okay. Hello, hello. Is my volume good now? Is it better? Okay, let's continue. So what are we doing? We free the memory for our basic memory pool, and now we need to utilize that. So we want it to be direct initialized. That means we want it. See, it says we need a reference to the struct, but no, I don't want a reference now. I want it to directly initialize. So I'm going to use the R value system here. So I'm going to use function overloading here. I have memory create and a memory create info and double AND. This is for our value. And here we do eclipse memory and eclipse create memory create, yeah. And here we do the create info, and now we can do eclipse memory create info and create info ci is equal to create info, and then return memory create ci. So that should be working, yeah. So we get working version 2096. Why is it mid block? Show context actions. So it wants me to do like that. Okay. I don't want to do like that, bro. That's why I made all that stuff. Let's see. Build failed because the size is not working. No member named size. Like there's a member, bro. What the hell? Line 8. Where's the line 8? In memory.cpp, it says the mem end is begin.create info.size. It should work. Let's see some other thing. Does not name a type. U64 does not name a type. That's pretty weird. It should not happen, but it's happening. That's because here, yeah, that's the problem. We should have a engine common types.hpp included here. And yeah, it works. Let's try allocating some memory. So we need a memory allocator here. So we need to allocate some memory. An allocation should return a void pointer, but no. I don't want that to happen. I want it to return the type itself. So I'm gonna be using a template called type name t, and then t pointer allocate, and then allocate memory from memory pool, alias memory pool. This is a memory pool, mempool, and U64 size. Yep. But the size is being given by the type, so we don't need that. What we need is how much instance do we need of that. So first make a simple one. No, let's actually make the main one from like U64 instances, and we can do that by checking if size of t into instances is more than mempool dots. No, we don't have a mempool size. We have a mempool end minus mempool current, and we convert that using static cast std static cast a u64. Damn, it doesn't work. Let's just use this. And if this happens, then we need to do is if it just checks the end pointer minus the pointer that is being allocated last. So if this happens, then we need to throw an exception, I guess. But we won't be using exception. We're gonna do something fun now. See, what we're gonna do is we're gonna include something called expected, and we need to put an expected here, std expected. We expect a t pointer, but if it doesn't happen, we return a error. That is, we couldn't allocate stuff, so we're gonna just return a std string. It's pretty bad, but yeah, I'm gonna do that. for now at least. We don't implement our own string implementation till then, we are do that, and that's great. So we do like an instances multiply and check if it's size, and if it is larger, not enough memory. So what we do is we return std unexpected, and we return it. Okay, so how do we use that? I just don't know. Unexpected std expected. Okay, how do we use that? Okay, so we directly return that like that. We return failed to allocate. Okay, let's just go with that. Oh, so does that work? I don't know. That's better. So we got unexpected. But now what if we have the space? So if we have a space, we return. We don't return actually. First we do is we give an output. So t pointer out. Okay, so AI is actually doing a good job here. Then, oh damn, like it just knows what I have to do. That's great. And just return the out. Wow. And it says me to use this, but it's not working. But now it works. That's magic. Or something I don't know. So we just do that and it's done. We don't need to make it in const. So that's how we do for instances, for multiple instances. But now if you have a single instance, for that, what we do is we allocate the stuff, but we don't take the instances part. And now what we do is we just do, we return allocate. Yo, it just knows. Oh no, it's done something wrong. That should be the thing. Allocate t. And that's it. Let's try using it. So we create a t pointer mempool. No, we create like a struct. Okay, we get a struct here. Test struct. It contains a yesterday string n is equal a is like something a u64 x a u32 y a std vector of an u32 z, and oh wow, we don't have vectors, leave it. And we have like a u32 100 of a z like 10,000 of Z. Let's put it like this. Now what we do is we create a test. Pointer T is equal to allocate memory by memory allocate. We need to allocate it for test main memory pool, and let's see. Okay, so what we'll do is dot value dot and then and or else then transform return. Okay, so we just do is this and dot value if t dot expected. We cannot just do that somewhat like here. So what we do here, we do is a and then okay dot and dot transform a const test and t. Okay, return t. It's actually test pointer return t. Or else we do like a const test pointer, and here we do a std, no, we do a eclipse logger log fail to allocate memory, or we can just do is like this log, and how do we get the error? Auto and e, yeah, that's better. Auto and e, we can just do like a e dot, we do like a e, this is for the error, and if there's not an error we can do an auto and t and then return t, a dereference to t and a dereference to e for t. So it cannot initialize. Okay, it cannot initialize. What's the problem? Cannot initialize local variable of type t. Let's just run and check. So we get an, oh, so it's saying an x. Okay. Okay. And then I do a huge blunder. I don't destroy memory pool. Damn, bro. I didn't even destroy the memory pool. Okay, now also we have an error. Let's first use a basic version of that by writing like a test auto t is equal to eclipse memory allocate T, that is test main memory pool. Wait a minute, if I just go to my memory and here, and you can do if t dot mm, unexpected, what is it? T dot error. If t dot has value, if t, then test t, test pointer, then an auto value. We can just non-initialize it. It's not possible. So test pointer t and tx is equal to t dot value, or we can just do that. Else eclipse logger log eclipse logger level error and t dot error argument detection failed. It says argument detection failed to allocate memory. Let's see if that works. If I increase the size of the memory pool from 0 to CPP 4096, does that work? Now that's a lot of memory. Okay, it works now. But we need to clean this up. We don't want this to be like that. So what we do is auto t is eclipse memory allocate memory for test main memory pool and then and then const auto and x return x dot or else or else so let's add marks perplexity that how to use std expected to get or to use expected with and then or else. Okay, so it says that here auto result get input if you want to use it for some other purpose, handle error, but that's what it is. and then or else, but it doesn't work. Yes, that's what I'm doing. We can just actually do a transform and return x, and or else const auto x and eclipse logger log x return null pointer. So what's the problem with that? I need to figure that out. Like it's hard to understand, bro, what's happening. This unexpected thing is too bad, bro. It's very bad. For me at least now. But what if you get a const std string here? A reference to string. Now it's happy. See that? Let's just pass it to the chat GPT and let's see what does it answer. You know, sometimes we can do that to save our time. It's gonna help, you know. Oh, so it returns. Okay. Else return x. Now I'm thinking like I should just create my own expected unexpected thing. It's gonna be better. I can create a better one. So I'll do that in another video. But now, you know what should I do? I should clean up this mess and just make it compile. It does compile, but it's too huge. So I don't wanna waste that much space. It runs. Done. Let's push it